right, let's go ahead and kick things off with this lecture survey question to start the day. Question was asking about policies that are creating inefficiencies or deadweight loss in a perfectly competitive market framework. And this is really a review from some Econ 1 material that you'd seen a while back, but about 20% of the class got this right, and that subsidies actually encourage agents to trade in a market where otherwise they would not be trading in a way that causes an inefficiency. So this is encourages what I'm going to argue are some quote unquote bad trades, bad in that they reduce total surplus. We're going to see that these other three policies today, price floors, price ceilings, and taxes, they also cause inefficiencies. They cause deadweight losses, but not because they encourage bad trades. It's actually because they prevent what are otherwise mutually beneficial, good trades from the perspectives of people that want to engage in them. So we're going to pick up with that idea in just a moment. In terms of the quiz this week, average is a little bit lower. Still a lot of high scores, so nicely done there. Lows at the other end of the spectrum, and the standard deviation was a little higher, and folks were a little bit more time constrained on this one. So again, hopefully you're looking where you are in these distributions each time. Relative to that average will wind up being around a B- for the course. There will be a quiz on Monday as well for what we are going to go through today and a little bit of what we had covered in the last segment on the partial equilibrium analysis. And that is what we are going to pick up with here. Yeah, you can see the number of people getting each score. That's what this histogram exactly is. That's what you are looking at here. It's exactly right. So let's go ahead and shift gears back to our lecture material. We're going to pick up about where we had left off last class. Yeah, it is showing. It was that exact same picture we were looking at a moment ago. That histogram shows exactly that. That is exactly what I was showing a moment ago when I had circled who had gotten what. So let's go ahead and we're going to pick back up with our agenda. I think last class we had talked a little bit about the competitive market recap. We discussed this notion of partial equilibrium, and we were kind of building up to this idea of surplus maximization. That's actually where we are going to pick up today. Before we jump into our applications of the partial equilibrium framework, which will include things like analyzing the efficiency properties of different price controls, taxes, subsidies, price floors, price ceilings. So we're going to get into a little bit of that today. What I do anticipate, and I alluded to this last class, is that I am going to post about 30 minutes of video content for these two topics in red here, which are another application of the partial equilibrium competitive market framework. I would like you to watch those 30 minutes of content either, sometime after class. It will be quiz relevant. There's maybe one or two quiz questions on that stuff. So it's not a majority of the quiz material, but it should let you kind of think about efficiency and surplus in a slightly different vein of thought. So there are 4 videos in the playlist. Yeah, I can't help that. Yeah, I don't know if it's zoomed or what, but you should be able to roughly gauge where people are falling. You don't need to know exactly what those numbers look like, but you should be able to roughly gauge where you're at there. That's the same information I've been providing all quarter. So you should be able to use that to think about where you're at in that distribution. With that being said, after class, you should have access to those videos. There's a playlist on YouTube. It's 4 videos. It's not more than a half an hour of content for you to digest there. So it's not even like there's a whole replacement lecture for the Thursday that we are missing. So the mini lectures, they'll be located in the recordings, and I will make them visible to you once class is done. Once I'm out of my 9:30 section, you should be able to see those there. So just keep an eye out for those. I'll shoot you a confirmation email again to kind of remind you that they are up and about. And again, it's only about 30 minutes of content. I'm not going to just, jam a whole hour and 30 minutes of content there. So with that being said, we had wrapped up last time by defining the total market surplus, right, as the area really between the supply and demand curve up to a particular point in terms of the quantity that is being traded. And this was the dollar value gain to all of the agents in the market and what we generally like to refer to as the quote unquote economic benefits pie that accrues to both buyers and sellers. The consumer surplus would be the buyer's piece of that pie. The producer surplus would be the seller's piece of that pie. And what we want to think about here is how the size of the total surplus changes as we were to consider changing Q, the number of units traded. So let's go ahead and take a look at this idea. What I have on the right half of the screen is the total surplus calculated at a particular quantity, right? It's the integral between the benefit curve and the marginal cost curve, right? Integral between marginal benefit and marginal cost. And what I want you to imagine we do is we calculate the area in the yellow, and then I'm going to plot that area, right? The value of that yellow region in the left-hand diagram, which is measuring the total surplus. Now, if I was to increase the quantity just a little bit to the right, just a little bit, what's going to happen to the yellow total surplus region? It's going to get what? Yeah, definitely is going to get a little bigger. And so if I plotted Q2 on the left diagram now, we should see that the size of the total surplus at Q2 has increased relative to where we were at Q1. If we do the same thing again, we increase Q2 a little bit here. What's going to happen to that yellow region? Going to get bigger. Yep, exactly. Okay, so there it gets a little bit bigger. And we can go ahead and at a quantity Q3, we can plot the increased total surplus. And now we're going to think about stepping again a little bit to the right past Q3. And once we do that, you should note that the cost of those units starts to exceed the benefit on those units at the margin, meaning if those are traded, it's going to cause what to happen to the total surplus? If the cost is bigger than the benefit, yeah, then we're going to get a marginal loss in total surplus if we were to increase, let's say, to an output level of Q4 being traded. So that pink area there, that is negative surplus. If we add that to the yellow area, which we still pick up as positive surplus, hopefully you agree that's going to cause the total surplus to go down relative to where it was at Q3. Okay, so what we've plotted in that left-hand picture is how the total surplus, the size of the economic pie, which we use to measure efficiency. Okay, the bigger that is, the more efficient the market outcome is. We can see here that the total surplus does indeed reach a maximum, and it reaches a maximum at what important quantity? Yeah, it reaches it at the equilibrium. Okay, where marginal cost equals marginal benefit. So hopefully you're kind of looking at this and seeing, hey, it looks like there's two ways that the economic pie will not be maximized. We either are in a situation like we are in the left-hand diagram where we kind of stop too early and we miss out on what would have been surplus enhancing trades, meaning the demand, the value to the buyers actually was greater than the cost to the sellers. So if we stop early, we miss out on realizing those mutually beneficial trades. And I'm referring to them as quote unquote good trades here. Okay, good in that they would benefit both parties. Hey, on the right-hand diagram though, hey, we're not missing out on mutually beneficial trades. We're actually causing too many trades. We're actually forcing some trades that must not have been mutually beneficial, right? Where the, again, benefit to the buyers falls below the cost to the sellers. So if those units do get traded It's going to cause the pie to shrink, but for a slightly different reason, not because we missed out on surplus enhancing trades, but because we forced surplus reducing trades. And we're going to see in a moment that price floors, price ceilings, and taxes cause the type of deadweight loss we see on the left, but subsidies will cause people to trade too much, do things they shouldn't have otherwise, and will cause the type of deadweight loss on the right. So folks are pretty astute in sort of seeing here that the quantity that does maximize surplus is the equilibrium quantity. So if we thought about solving this problem, right, let's figure out, like suppose you're the government and you want to figure out how much could we force people to trade so that we maximized the total gains from trade. We maximize the size of the pie. Okay, well, what that requires us to do is to optimize this integral. And if we want to optimize something, we got to take the what? Yeah, very good. We have to take that derivative. Okay, now what happens if you take the derivative of an integral? Anyone remember? And derivatives and integration, they're related to each other as operations. How are they related? Yeah, they're like really inversely related. So if you take the derivative of that integral with respect to Q, what do you get back? You just get back what's inside the integral. So if we wanted to solve this problem, hey, let's try to maximize the total surplus. Well, the first order condition here tells us that surplus is only going to be maximized if the marginal benefit of the last unit equals the marginal cost of the last unit. And that is literally saying that is where the supply curve and the demand curve cross. So even if we solve that analytically, we should see that the equilibrium quantity is the solution to the problem of trying to maximize the economic pie in the market. Now, why is this important? Well, we mentioned Adam Smith's invisible hand result last time, and I suggested that this is really the crux of that result, right? For example, what did the government need to do to move the market to equilibrium? What needed to happen? Did the government need to tax people or use price floors or price ceilings? Yeah, they didn't have to do much. It wasn't the government that pushed things to equilibrium, right? It was the buyers and the sellers that were pursuing their own selfish gains. And we saw that if you let them do that, that pushes the market to equilibrium. And that also happens to be the volume of trade that maximizes the total gains from trade. So this is the idea that if you let people kind of be selfish and you don't regulate them too much, if they're in this competitive market framework, right, the perfectly competitive framework as we've described, then that leads to an equilibrium where there's this nice societal result. The benefits pie on net is as big as it can be in a market. Okay, so when people say, hey, markets are efficient, this is the result they're referring to. But they're often misusing this result because, as we've argued, most markets are not perfectly competitive, if any. So, what does the government have to do if they wanted to maximize surplus in the market? Well, we just said they don't have to do anything to push the market to equilibrium aside from protecting what? We said there's an essential function we need government for, actually, for a market to work at all. And that is at minimum, yeah, Isaac, I like what you're saying. At minimum, we need to protect property rights, meaning they're clearly defined, they're clearly enforced, and clearly interpretable. Okay, so this last bullet point here really suggests that, if anything, we still need government. We just don't need the government to really be putting its hand in the cookie jar more than protecting people's property rights. Okay, so what we're going to argue in a minute is that if we have any policy that causes Q to move away from Q stall, then we're either going to be in the left situation where we've blocked some mutually beneficial trades, or we're going to be in the right-hand situation where we've engendered some bad trades that are surplus reducing. So let's go ahead and start off doing a little bit of abstraction by thinking about a price floor. A price floor, if it's binding, if it's going to cause a problem, got to be set above equilibrium. Okay, if it's set below equilibrium, then the market can still reach equilibrium and the pie will be maximized. But if this price floor is set above equilibrium, hey, who does not like that the price is artificially high? Who is that really bad for? Yeah, that's right, wrong amount. Buyers are not happy about that. Who's kind of happy that the price is high? Sellers are, right? Until they realize that there's not going to be enough buyers around to buy everything they sell. And we looked at this situation last time. What is this called again? Looks like the supply exceeds the demand. That's a what? Yeah, that is a surplus in the market, right? That is a surplus. Not necessarily caused by a price floor, but if the price is too high, that will cause a surplus. So if the price floor is holding P above P star, okay, let's think about this. The buyers want to buy some units, but the sellers produce a lot more. So how many units will actually get traded? Like if buyers want to buy 2, but the sellers make 5, how many units would actually get traded? Yeah, just 2. Hey, what happens if the sellers made 1 and the buyers wanted 10? How many units would get traded in that case? Sellers make 1, buyers want 10. Yeah, just 1 unit. So if supply and demand quantities are not equal, whichever one is lower is going to define the actual volume of trade. Now, we recognized before that when you have this surplus in the market in terms of excess supply, that there's this downward pressure on the price because firms want to cut that price to get rid of that excess inventory. Problem is, they cannot cut it lower than the floor now. That's a legal mandate preventing them from dropping the price any lower than that. So the quantity of trade here is going to be defined by the smaller of those 2 supply and demand quantities, in this case being the demand quantity. And this should make sense. If the price is artificially high, who is deterred from participating in the market? It's not really the sellers, it is the buyers. And so because the buyers kind of leave the market, right? We're in this situation where the quantity of trade is now lower than Q star. And I'm going to suggest that is associated with the deadweight loss, where we are missing out on some surplus enhancing trades. We're missing out on these units being traded in that green interval, where the benefit to the buyers along the demand curve is greater than the cost to these sellers along the supply curve. But the problem is, in order for those buyers and sellers to be able to negotiate to a price that's mutually beneficial, the price floor would have to come down, and it doesn't, right? The government keeps it up. So what I would like us to be able to do here is to apply some distributional surplus analysis by thinking about how the economic pie is allocated before the price intervention from the government versus what happens to that allocation and distribution of surplus after the intervention. Okay, so let's for the moment forget about the red line in this diagram, and let's suppose we're in the equilibrium where the price is P star and the quantity is Q star. If we're in the equilibrium, which areas in this picture define the consumer surplus? Yeah, very good. Should be A, B, and C. I like that. Excellent work there, Kelly. Which means then the producer surplus in the equilibrium has to be accounted for by what? Yeah, gotta be DE. So if we added the consumer's piece to the producer's piece, then the total surplus in the market will be A, B, C, D, E. And we've argued that in the equilibrium, that's as big as that total surplus can possibly be. Now, what we would like to do here is to compare this allocation to what happens when we are effectively restricted away from equilibrium by the price floor, right? That drove the price up, and as a consequence, it reduced the quantity traded down. Now, with the restriction, let's think about the consumer surplus. The area above the price, below the demand curve, to the left of the quantity traded, that means the consumer surplus shrinks to A. Very good, folks. Excellent. So note, it looks like the buyers are losing something. Is that right? The buyers are losing B and C together. From that price increase. However, if we think about the producer surplus, okay, the producer surplus is the area below the price, above the supply curve, to the left of the quantity traded Q tilde. What is the producer surplus in this case? Yeah, very good. It should be B and D. There's our producer surplus. All right, so notice the producers kind of lost something too. Is that right? What did the producers lose? Be careful. Producers weren't getting C before, right? They were only getting what? Yeah, that's right. So producers, it looks like the producers here are losing E, but I'm going to argue that things aren't super sad for the producers, because why? They got B. Is that right? Producers gained B. Okay, so notice some of what the consumers lost, the producers were able to recapture. Okay, now, are the producers better off or worse off than they were in the equilibrium? Right? They lost something, they gained something. So are they better off or worse off? Like they lose E, but they got B. Geometrically, this graph, I'm going to tell you, assume it's drawn to scale here. Right? They're still getting D. They were getting D before. So I'm going to argue D is not really important. The producers lose E, but they gain B. Which is bigger, B or E? Yeah, B is definitely bigger. Okay. However, I will just say this is an important side. If we were to move that price floor all the way up, like we move it even higher, and suppose we move it all the way up there, how many units would be traded if the price floor was set all the way up at the demand curve intercept? Yeah, nothing would get traded then. Okay, so what I'm suggesting here is if that price floor is set too high, not only will it make buyers worse off, it can also make the sellers worse off. But if it's not too high, okay, if it's where we've drawn it, it's possible that this mechanism can be used to transfer welfare, to transfer surplus from the buyer's pocket into the seller's pocket, right? Think about who we're helping when we try to use a price floor. We're trying to really help the sellers out here. Okay, so we should be able to see here that the total surplus now shrinks to ABD, even though the producers are better off. The producers are better off consumers are worse off. So if the producers can lobby for this, will they lobby for this? If they can bribe their politicians to put in this price floor, will they do that? I'm arguing they will. Even though we can see here that this is not an efficient thing to have happen, right? The pie shrinks. We're missing out on C&E. Who captures C&E? Answer is nobody. So the whole pie is shrunk, but the producers are getting an even bigger piece than they were before. So they don't care if the whole pie shrinks. All they care about is their producer surplus, right? Their profitability. Yeah, jerks, right? So here's what we're able to see. That price floor is preventing some mutually beneficial trades. It is discouraging buyers in the market from participating because the government's holding the price artificially high. These buyers, right, along this green part of the demand curve, they would have all been willing to trade at the equilibrium price. And they would have been able to trade with these sellers that all have lower costs, which would have caused the pie to get bigger. But the price floor is preventing these trades from taking place in this region. Okay, so the price floor, we miss out on some good trades, not because the sellers are leaving the market, but because the buyers don't want to be paying that higher artificial price. Now, let's apply the same set of tools here, but let's think about a price ceiling instead. Okay. Suppose we have a price ceiling that is binding, meaning it is preventing the market from reaching equilibrium because the ceiling is set too low. By the way, if you're a policymaker and you're trying to use a price ceiling, right? Like in San Diego, we recently put a price ceiling on the rental market. Who are we trying to help? Yeah, we're trying to help the buyers in that market, right? Let's try to make things more affordable. More affordable housing means more available housing, right? Got to be careful. In many cases, our intentions of trying to help one party often can have unintended consequences. Okay, now, if you have a price ceiling, I'm going to argue that when the price is held artificially low, the buyers are kind of thrilled, but this drives off who? Yeah, it's going to drive off the sellers. So now we're going to wind up in an excess demand situation where we have a shortage. And you're like, wait a minute. I thought we used things like rent control, right? Capping the price to make housing more available and affordable to try to fix the housing shortage. Bad policy, I'm going to argue. Okay? If you try to use a price ceiling, a cap on rents to fix the housing shortage, guess what you're actually going to do? Yeah, you're going to make it worse. You will actually reduce the availability of housing through this, even though the intention was nice. Now, normally when there's a shortage, right, there would be this upward pressure on that price because buyers want to start trying to outbid each other for apartments. Hey, I'll pay a little bit more than them if I can get to live there. But the problem is the government now has put a strict mandate on how high that price can go. And I'm going to argue that is also preventing mutually beneficial trades, just like the price floor. The only difference is the price floor kind of deterred the buyers, sellers from the market rather, whereas the price floor deterred the buyers from the market, whereas the price ceiling is actually deterring the sellers from the market. So the actual quantity of trade here is not going to be determined by the demand quantity, right? That's bigger. At least at any time the quantities supplied and demanded don't equal each other, okay, the one that is smaller is going to define the quantity traded here. So in this case, the volume of trade is going to be defined by the quantity supplied. We should also be able to note that this is reducing the volume of trade. We're on the left-hand side of the equilibrium, meaning, again, this price restriction is preventing some mutually beneficial trades from being realized. Okay, and those are these trades in this region. So we're seeing something pretty similar, right? Price floors, price ceilings, they both prevent mutually beneficial trades. They're both going to cause a deadweight loss. Okay, the difference is which market agent is trying to be helped and which one is trying to be hurt. Okay, so the price ceiling. Let's think about the distributional effects. If we did not have any price ceiling and the market was allowed to reach equilibrium, okay, then the consumer surplus in this case would be what? Yes, it's going to be A plus B. Very good. And then in equilibrium, the producer surplus would be, right, yep, C, D, and E. Okay. So again, if we're in equilibrium, the pie is at its maximum value. That's as big as the total surplus could be, right? This is the efficient market outcome. Unfortunately, if we have that price restriction driving the price down in the market, and we argued that deters the sellers and reduces the volume of trade, meaning we're going to be missing out on some mutually beneficial trades. So if we have the price restricted down to P bar, what is the consumer surplus now if it's the area under the demand curve above the price to the left of the quantity traded? Yeah, very good. It should be A plus C. Okay, so notice here, it looks like the buyers lost something. Is that right? Buyers lost what? Yeah, buyers lost B. Okay, so we'll make a note of that. The buyers lost B. But it looks like the buyers are maybe okay with that because they, at the same time, gained what? Yeah, they're gaining C. That's right. Buyers gained C. And we can see here, assuming things are drawn to scale, that C is bigger than B. Meaning the buyers, are they better off or worse off? Yeah, they're better off. Absolutely. However, if we had set that price ceiling too low, if we go too low with it, then it's possible that C will be very, very small. And B can become very, very big. So I want to be clear. If you're a policymaker and your goal was to maybe help consumers, there's a place you could set that price ceiling that will make A and C as big as possible. And you could think about trying to optimize that price ceiling for the benefit of the buyers. Okay, but we should see here, if that price ceiling goes too low, then not only is it going to hurt the sellers, it could potentially also hurt the buyers if we're too heavy-handed with that regulatory tool. Now, unfortunately, the producers only get how much of the pie in this case? Yeah, they're only left with E here. And so we should be able to see that the producers lose something as well, right? Producers are losing D. And they lose what? In fact, let me go back. The producers only wound up with E, is that right? So they've actually lost more than just D. They've lost C and D. But the consumers recaptured part of that, right? They took what was producer welfare and now it's in the buyer's pocket as consumer surplus. So we can see here really the producers lose C and D. Okay, but the buyers recaptured C. Okay, but we can still see no one is getting B or D now. So we have a deadweight loss equal to the areas of B and D. That is representing the shrinkage of the economic pie in this case. So that being the situation. And we can argue again that the price ceiling, similar to the price floor, is driving off some mutually beneficial trades. It's not really the buyers driving things out here. It's the sellers leaving the market that causes the volume of trade to drop, right? It's discouraging sellers who wanted to sell at a higher price. Again, those trades that are prevented, right? Buyers would have been willing to make a trade, right? These buyers along the green part of the demand curve would have been willing to make a trade with these sellers along the red part of the supply curve, except in order to negotiate that trade, the price would have to be higher. And the price ceiling is preventing that interaction from taking place in this region. We're not able to realize those gains. So we should be able to see here, both the price floor and the price ceiling have very similar efficiency effects. They both cause deadweight loss by reducing the volume of trade. And I want to shift gears towards taxes. And taxes are kind of strange. We levy taxes for really three main reasons. Anybody know why we have taxes? Why do we? Yeah, we got to raise money for the government. Okay, do things like funding public goods, infrastructure. Yeah, the property protection, exactly. Paying for police force, fire, etc. Yep, that's one reason we tax stuff. Anyone else know why we tax things? Like cigarettes, alcohol. Yeah, Isaac, I like what you're saying. Yeah, we do this to try to like incentivize behavior. Right? Like if we want to deter smoking, or we want to reduce the quantity of imports, for example. Dylan, I like your example there, right? We tax imports with tariffs to try to, change incentives about importing. There's a third reason we also tax. And this is one that maybe Bernie Sanders is a little bit more behind than other folks are at this point. But most economists agree that this is absolutely a legitimate role for the government to play. And that is to redistribute welfare. Right? Transferring surplus between buyers and sellers. Right? We saw price floors and price ceilings do that, right? A price floor transferred surplus from the buyers to the sellers, hurt the buyers, potentially help the sellers. But a price ceiling did the opposite, right? Hurt the sellers, but buyers captured a piece of that back. So we transferred well-being, welfare between the buyers and the sellers in the opposite direction relative to the price floor. Now, the government, as you're aware, can make the sellers pay the tax at the point of sale, or they can make the buyers. For example, when you go and you pay your sales tax, right? You buy a candy bar for $1 and you wind up having to pay like an extra 8 to 9 cents, depending on the tax rate in your area. So that's an example of where the buyer has to pay the tax, right? At the point of sale is the sales tax. There are other types of goods, for example, like excise taxes on alcohol and gasoline, where the seller actually has to pay the tax. Okay? But what does the seller do? They build that into the price they charge. And even though the seller physically has to pay the tax, I'm going to argue, regardless of who actually has to pay it, the tax does affect everybody to an extent. And the extent to which it affects a market agent who's not actually being taxed may be surprising, especially the features of the market that lead to the tax incidence falling on one agent more heavily than another. Now, as you're probably aware, taxes can be specified as a percentage of a good's price, kind of like how the sales tax is. Or we can use a per unit tax, which is a constant dollar amount for every unit that is purchased. And for simplicity, without too much loss of generality here, in fact, all the important lessons will bear through for both cases, but for simplicity, I'm going to consider the per unit tax case only here in this situation. Okay, so I want you to imagine we're looking at the market for pizzas. And in equilibrium in our college town, the price of a pie is $10 and 500 pizzas are both bought and sold in the market equilibrium with no tax. Now, what I want us to think about is what happens if we had levied a $1.50 tax on specifically the buyers. The buyers are responsible for paying this. Okay, well, I want you to imagine you're the individual who paid $10 for the 500th pizza. Suppose that's you. And you're the guy standing right on the equilibrium point of the demand curve. If the government says, hey, we're going to now take an extra $1.50 from you. If you were willing to pay 10 in total, how much are you willing to pay now if the government's going to force an extra $1.50 on you? Yeah, Dylan, I like what you're saying there. Yeah, hopefully everyone agrees that if you were willing to pay 10 before, but the government's going to force you to pay $1.50, then that's going to cause your willingness to pay for that same pizza to go down to $8.50, right? Still in total, you will be spending 10 bucks, but $1.50 of that goes to Uncle Sam. So I'm going to suggest what taxing a buyer $1.50 does is it literally shifts every point on the demand curve down by exactly that much. It's going to reduce your willingness to pay by the size of the tax. And this is true if I was buying that 500th pizza. This is true if I was buying the first pizza. All right, now, if you remember your equilibrium analysis from Econ 1, we started at one allocation. Looks like we had a demand curve shift, right? And what's going to happen to the volume of trade? New point, right? What happens to the quantity traded? It's going down. So just like the price floor and the price ceiling, right? The tax is causing the volume of trade to go down, which means I'm going to argue that it must be preventing some mutually beneficial trades. Now, the other thing that's important to realize here is a tax results in a situation where buyers and sellers are no longer facing the same prices. In fact, that $1.50 that the government is collecting, what that does is it causes the price the buyers pay and the sellers receive to diverge. It puts a wedge in between those prices. And if we were to go up to the supply curve at $4.50, right, we should be able to figure out the price that sellers are willing to accept according to their marginal cost. If we go up to the original demand curve, we should be able to figure out the price that the buyers would be willing to pay as well. Is 450 just a random number here? No, it's not. I don't have equations and things to go with this example, but we'll work through a numerical example in just a moment. The point is, we should be able to see that the quantity of trade falls here. And as a consequence, the prices the buyers and the sellers face also change. Right? In equilibrium, everyone was paying and receiving how much? Like per unit. Yeah, 10 bucks. Okay, but notice with the tax, the price the sellers face is now lower, right? Sellers, in terms of the price they're receiving, are 50 cents worse off per unit. The buyers are also worse off. They were paying 10 before. How much are they paying now? Yeah, they're paying a higher price of 11. So I'm going to argue here that the tax has caused not just one agent to be worse off, it's caused both the buyers and sellers to be worse off. Sellers are getting a lower price. Buyers are at the same time paying a higher price. And where does the difference between those things go? Yeah, that's right. If you take the tax per unit and you multiply it by the number of units, that green box is what? Yeah, it's the tax revenue, that whole green area, right? The vertical distance here is the size of the tax. But if I multiply that by the 450 units traded, then that area is the total amount of tax revenue generated to the government. Now, it's important to remember here, we made who pay the tax? That's right. We made buyers pay the tax. But does this still affect sellers? Answer is does. And so something strange is kind of going on here, right? If we look at the burden or the incidence of the tax, we can see here in this example that it looks like buyers are paying like $1 of that $1.50. Sellers, though, are essentially paying the other 50 cents by facing that price reduction from this tax switch. So again, I'm going to argue that what that tax is doing, okay, is it's driving a wedge between the price the buyers pay and the price the sellers are receiving. That is what it is doing. Okay, why $9.50 instead of $8.50? Well, if it was down at $8.50, the difference between $8.50 and $11 is not a $1.50 tax. It will be $2.50 tax. So remember, the difference between those prices has to account for the size of the tax. All right, now if you're wondering, why did it go up more for the buyer than it went down for the seller? We're going to get back to that in a moment. I think you'll start to see why that is the case. What I would like to do for the moment is I want to come back and imagine instead of us taxing the buyers, we instead levy that same $1.50 tax on the sellers. Same size tax, but instead of the buyers paying it, which we argued reduced their marginal benefit, their willingness to pay, now we're going to force the sellers to pay it, which effectively is going to increase the sellers what? For every unit. It increases their marginal cost. If only we had a function in this graph that captured the marginal cost to the seller. Do we? Supply curve does that for us. Okay, so if the marginal cost is $1.50 higher, what's that going to do to the supply curve? Yeah, Dylan, they're still paying $1.50 tax for the pizza, but the sellers aren't asking for as high of a price anymore. That's why that's happening, right? Sellers are not getting the same $10 they were before because the quantity reduced and the marginal cost to the sellers went down. Hope that makes sense. We're going to go through a mathematical example in a moment where you should see this happen exactly. Now, if we tax the sellers, I'm arguing just like we shifted the demand curve down, this is going to shift the supply curve up, right? The supply curve is the marginal cost. And we've argued the marginal cost for every pizza is now going to be $1.50 higher for every seller. We can think again about looking at the new equilibrium compared to the old equilibrium and take my word for this. Okay, but not much is going to change. If you're wondering, oh, is that volume of trade down to 450 the same as what it was when we taxed the buyer? The answer is yes. And if we were to go up to the supply curve before tax to think about the price the sellers are going to receive, and we were to go up to the demand curve before the tax to think about what the buyers are willing to pay at 450 units, we will also see something very familiar here. Buyers are paying $11 per unit. Sellers are receiving $9.50. And again, the difference between those prices accounts for what? Yeah, it is the tax wedge. Okay, so there's something strange to this story here. And let me put both pictures up side by side. Right? In the left picture, we levied a tax on the buyers. Okay, in the right picture, we levied the tax on the sellers. Can you tell me what is different about the resulting allocations? Is there anything different between the prices and the quantities that result? Yeah, nothing's different. Notice in both cases, okay, the volume of trade is 450 units. In both cases, the sellers are receiving $9.50. In both cases, the buyers are paying $11, which means in both cases, it looks like the buyers are paying $1 of that tax. The sellers are only being hurt by 50 cents of that full $1.50. So it's kind of weird. The outcome is the same regardless of who we actually made pay the tax, which might make you wonder then, well, if who we make pay the tax doesn't have to do with how much agents feel the pain of the tax, what does? Okay, what does, right? Looks like no matter if the buyers or the sellers are paying the tax, look at what happens to the buyers. They wind up paying $1 more in both cases. So buyers are like $1 worse per unit. Sellers are only 50 cents worse per unit, even when we made them pay it, which is weird. Now, if you're wondering, hey, do we even need to worry about the curves shifting? I'm going to suggest the answer to that question is no. It doesn't matter who we taxed. All that actually matters here is the following. The tax drives a wedge in between those prices, right? The tax is driving the price the buyers pay above the price the sellers receive. The bigger the tax is, the farther that green distance is. So all we have to do is think about, let's take the size of the tax, regardless of how big it is. Let's take that and let's wedge it in between the supply and demand curve until it fits just snug. And then we can look straight down to figure out how many units will get traded. Once we know how many units get traded, then we can go back up to the original supply curve and the original demand curve to figure out the prices that the buyers and the sellers would be paying. Now, if it's not who we make pay the tax that defines how the burden of the tax is distributed between buyers and sellers, what does? And I'm going to argue it all goes back to elasticity. Okay? Let's imagine a situation where the supply is more elastic than the demand, meaning we have a pretty vertical demand curve, but we have a relatively flatter supply curve. If there was no tax, right, our allocation would reach equilibrium as usual. But imagine we take a tax and we wedge it into the left side, right? If we look straight down, we should be able to see, okay, that tax is going to reduce the quantity traded relative to the equilibrium. And we can see, hey, the price the sellers pay goes down a little bit. But what happens to the price that the buyers are going to pay if that price is based off of this marginal unit here? It goes up by like quite a bit. So you should notice in this situation, right, supply is more elastic, meaning sellers are more responsive. So when the pain train comes, right, the tax is the pain train. Who's able to be flexible and get out of the way and get off the tracks? Yeah, the sellers are. They're more elastic. They're more responsive. So the sellers can avoid that pain. The buyers, on the other hand, are less elastic. So when that price increase hits the buyers from the tax, the buyers cannot really change what they're doing. So in this situation, right, the buyer's share of the tax burden is larger than the seller's share. And this is regardless of who we actually make pay that tax. So it's easier for sellers to leave than it is for the buyers, meaning the buyers are going to pay most of that burden. They're going to face most of the incidence of that tax burden. If we flip this around and we considered a market where the buyers were more elastic, here the supply curve is a little bit more steep. Okay, then in this situation, if we use the same size tax wedge, that orange line is the same size as it was in the last slide. Please take my word for that. You should notice now, in this case, when the quantity of trade is reduced, it only pushes the buyer's price up a little bit, but it really adversely affects the sellers. Now, in this case, the buyer's share of that tax burden is relatively smaller and the seller's share is relatively larger. And that's because, again, when the pain train comes, when that tax comes and it hurts everybody, right? Buyer's price is higher, that's worse for them. Seller's price is lower, that's worse for them. It's easier for the buyers to leave the market and get out of the way, which is why in this particular case, the sellers bear most of the burden of the tax. Okay, so regardless of who we make pay for it, and this is something we have to be careful of, right? If we're going to go and try to tax the rich, are we actually taxing the rich? This is an important question we're going to have to think about. So let's think about the distributional effects of the tax here, right? With no tax, the market reaches equilibrium. But when we wedged a tax of size T in between there, right, this drove the buyer's price up relative to the equilibrium. It drove the seller's price down relative to the equilibrium, and it reduced the volume of trade. Okay, so what we want to be able to do here is think about our distributional analysis, just like we had done with price floors and price ceilings. But we're going to have to now remember that Uncle Sam is putting his hand in the cookie jar, and he's taking a piece of the pie for the government. And the piece of the government pie is literally the tax revenue. So when we want to think about the total surplus, generally that's consumer surplus plus producer surplus. But now we're going to have to think about part of that consumer surplus goes to tax revenue. Part of that producer surplus goes to tax revenue. So we're going to have to think about counting the government's piece of the pie as well. And we're going to treat the government's piece like it's a positive piece of surplus, because ideally that tax revenue will be used to do things like, fund goods and services for public consumption. So when it comes to looking at the distributional effects of the tax, right, we want to be able to apply this surplus analysis from welfare economics, just like we had done with price floors and price ceilings. So we're going to think about the consumer's piece, the producer's piece, and the government's piece, both in the free market equilibrium with no tax. And then we'll compare that to the market when we do have the tax present. Right, so very similar type of idea here. So I think this hopefully is going to be a familiar idea to think about here. Now, if we did not have any tax and no government intervention, consumer surplus in this case should be what? It should be ABC. That's right. Should be ABC. Okay, producer surplus then in equilibrium without the tax, got to be DEF. Okay, so hopefully we can agree that in the equilibrium, the government doesn't take any of that total surplus. So the total surplus is ABC DEF, right, our fully maximized pot. However, if we have a tax, this drives the buyer's price up to PB and it drives the seller's price down to PS. So that being the case, if the buyers face PB, what is the consumer surplus reduced to now? Yeah, if the buyers are paying PB, their surplus is only going to be triangle A. If sellers face PS, what is the producer surplus going to be? Yeah, just F. Very good. Now, do we have to worry about the government collecting a piece of pie here? Oh, we do. Which piece is the government taking? Yeah, they're taking B and D, absolutely. And you should be able to see that part of that comes from what would have been buyer surplus. Part of that comes from what would have been seller surplus, right? B was coming out of the buyer's consumer surplus. D was coming out of the seller's producer surplus. Okay, so the government, again, is taking a chunk of both people's surpluses. And notice no one is getting what? Yeah, no one is capturing C or E, which means buyers are worse off. Their surplus went down. Sellers are worse off. Their surplus went down. So if you ask, who wants to vote for taxes? Generally, that's who. Who likes taxes? Yeah, nobody really likes taxes, right? Government maybe likes taxes, but otherwise buyers don't like them, sellers don't like them. Okay. Now C and E, that should be familiar, right? That is the deadweight loss from taxation. And again, that is being caused because the tax is preventing mutually beneficial trades from taking place. There are these buyers along the demand curve whose marginal benefit exceeds the marginal cost of these sellers along the supply curve. But the problem is the government will not let those buyers and sellers negotiate those prices closer. The tax prevents those prices from moving any closer. It's a wedge preventing those prices from moving closer, meaning these units here would have been mutually beneficial trades in equilibrium without any tax, but now those trades are prevented. Okay, so if we had to calculate the welfare loss from this tax, all we need to know is what is the reduction in quantity, right? Let's look at that reduction in quantity, and then we can compute the associated integral, right? Or if you have linear functions, you calculate the area of the triangle, but this is a little bit more general here. Okay, so we've seen now, in terms of distributional analysis, that the tax, just like the price floor and price ceiling, reduces mutually beneficial trades, right? It reduces the size of total surplus. It creates a deadweight loss. So let's go through a numerical example. Okay, suppose we have a demand curve given by 100 minus Q. Suppose we have a supply curve given by P equals Q. What we want to do is consider the effects of levying a $10 tax on this market. And again, it doesn't matter who actually pays it. We should be able to see that. So I'm not going to worry if it's the buyer paying it or the seller paying it. What we're first going to do is figure out what is the volume of trade by describing mathematically the tax wedge between the prices paid by the buyer and the price received by the seller. Okay, mathematically, I've been suggesting the following. Okay, I'm going to use this Greek letter tau for the size of the tax. Okay, so this tax is saying, hey, the prices between the buyer and the seller have to be $10 apart. So what they're asking us to do is to wedge a $10 tax in between the supply and demand curve snugly. So we're going to use this equation here that describes that tax wedge. And all I'm going to do is I'm going to plug in our demand curve and our supply curve into this expression. And that's going to give us an equation that lets us figure out the Q that gives us exactly a $10 wedge between the demand and the supply. What quantity does that? What quantity does that for us here? Yeah, should be exactly 45 units. Very good. Should be 45 units. If the tax was zero, the equilibrium in this market would be what? Yeah, if the tax was zero instead of 10, and you solve that same equation, you should find that the equilibrium quantity was 50. So we can see here for sure, the tax is causing the volume of trade to drop, which is pretty consistent with what we had suggested. It's preventing these mutually beneficial trades. Now, if I want to know what is the price paid by the buyer and the price received by the seller, all we have to do is take 45 units and we can plug it into the buyer's demand curve and we can plug it into the seller's supply curve. Okay, and that'll allow us to fully describe the equilibrium allocation with the tax, right? What prevails when there's that intervention, right? Buyers are going to be paying 55 bucks. Sellers are going to be receiving 45 bucks. Okay, notice the difference in those prices accounts for exactly the $10 tax wedge. So just to kind of summarize the results of this example here, right? We have this tax. Okay, in equilibrium, the price was 50 and the quantity was 50. But when we put that tax in, it drove the buyer's price up by $5 and it drove the seller's price down by $5. What do you notice in this particular example is true about the incidence or the burden of the tax on the buyers and the sellers? What's true about that incidence on the buyers and the sellers? Yeah, they're both paying equal parts of that tax incidence, right? Buyers pay 5, sellers pay 5. What does that tell you must be true about the elasticities of supply and demand at the equilibrium? If they face the same incidence, what must be true about their supply and demand elasticities? Yeah, they must have the same magnitude of the elasticities. Remember, demand elasticities are usually negative because it slopes downwards. Supply elasticities are usually positive because the supply curve slopes upwards. Okay. So what we are seeing here is we actually have a situation where the burden is equal on both agents, which means their elasticities, they must have been equally responsive to prices in the original equilibrium allocation. Right now, we wanted to shift gears and think about a subsidy. I'm going to argue subsidies are pretty easy because they are literally a negative tax, literally a negative tax. So if we wanted to think about the same problem, but with a $10 subsidy instead of a $10 tax, then all we would do is we write out the tax wedge and we would plug in a negative value for the tax. Instead of a positive $10 tax, we have a negative $10 tax, which is the same as a $10 subsidy, which means with the subsidy, the seller's price that they receive is actually more than what the buyers pay. And if you're wondering how is that possible that a seller could receive more than a buyer pays, it's because who is paying the difference? Yeah, government is paying the difference, absolutely. So if we were to think about this same example, right, but with a subsidy, we just take that subsidy wedge, we plug in the supply and demand curves, and again, we get an equation that lets us solve for Q. If we solve for Q for the $10 subsidy, how many units will get traded? Yeah, very good. It's exactly 55 units. Notice that's more than the equilibrium quantity. And this, there's a little bit of a typo here. This should say not the tax is preventing mutually beneficial trades. It should say the subsidy is encouraging surplus reducing trades. We should be saying here, the subsidy is reducing surplus enhancing trades. Sorry, the subsidy encourages surplus reducing trades. That's what I meant to say. I apologize, but this is correctly written. Okay, as we kind of suspected. Okay, now if I want to know what prices do buyers and sellers pay and receive, again, all we have to do is take that 55 units, plug it in the supply curve, take that 55, plug it into the demand curve, and we should be able to see here in this case, buyers are now paying $45 and sellers are receiving $55. I think this is a good place for us to wrap up. So I'm going to add just one very, very short video that kind of runs through the surplus analysis of the subsidy. The subsidy is kind of weird. Just like a tax, we don't have to worry about shifting the demand curve up or shifting the supply curve down. Doesn't really matter in both cases. The subsidy allocation will be the same, just like we saw with taxes. The only difference really where subsidies dramatically differ from taxes, price floors, and price ceilings is this is the only policy in the competitive market where the government intervenes and it causes the quantity of trade to go up above the equilibrium. So if you're conducting surplus analysis, and again, I'll post a video because I'm going to go through this kind of quickly just for the moment, but watch the video, it'll go through it, and I think it'll also kind of be good to see it again. We should be able to see the consumer surplus is A and B, the producer surplus is C and D with no subsidy when we reach equilibrium. So total surplus is A, B, C, D. But when we have a subsidy and it pushes the price the buyer faces down to PB, okay, then the consumer surplus actually increases. Okay, the buyer's gain, C, E, and F. Right, because buyers are paying a lower price. At the same time, the sellers are receiving a higher price. So I'm going to argue that unlike the tax, the subsidy actually makes every agent individually better off. And you'll notice if we add those pieces together, right, the consumer's piece and the producer's piece, there's a big chunk of wedge that we've counted twice when we calculate the total surplus. We got B and C there counted twice, but we cannot forget about the revenue. Now, the tax revenue we treated like a good thing because that's money we raise to provide goods and services. But the subsidy revenue, we're going to treat like a negative piece of pie. We take that away from providing goods and services to facilitate this market outcome. So if we think about subtracting this pink region relative to what we were looking at a moment ago, where we had counted B and C twice, then what you will see is when we subtract B, C, H, E, F, and G one time from what we were looking at a moment ago. Okay, B and C will still be there because we've counted them twice, but H, E, and F go away, and G, which we never counted before, winds up actually being that pure deadweight loss region here. Okay, so the deadweight loss, right, when we produce too much, we trade too much relative to equilibrium, we can compute that, again, with a similar type of integral form, integrating from Q star to the higher level of output. So to wrap things up here tonight, and again, no video you have to worry about really for the subsidies. I think just the international trade stuff I want you to watch should be about 30 minutes instead of a full hour and a half of class. But note, we can make the following predictions here, right? If you have a tax, it's going to reduce the volume of trade, just like a price floor and a price ceiling did. But a subsidy will increase that. Okay? And both policies are causing deadweight losses in the competitive market model. The other thing we saw that's important is that the incidence of the tax has very little to do with who we actually make pay it, right? It has everything to do with the relative price sensitivities of the buyers and the sellers. So with that being said, I'm going to wrap things up here, do a little bit of rapid fire Q&A in the chat. If you have a couple questions, I know a couple people have put longer questions in there. I did not get to those. I apologize. But if you want to follow up with me individually, happy to do that. Otherwise, you are free to go. Remember, keep an eye out. LRPs and LSQs for Thursday's class we don't have. They're still there, so you get some practice and you get those points. So do not forget about those. There will be a quiz on Monday as usual. It will cover this partial equilibrium stuff as well as a little bit of the international trade stuff in the remaining videos. I think I had also mentioned last class that since we are going to do a little bit of video content for not having class on Thursday, I'm going to kind of try to reward everyone, and I'm going to try to give everyone off on Thanksgiving week. So no class on Tuesday is what I'm planning. And then we also will not have class on Thursday of Thanksgiving. So I'm not going to call that week 9. That's just no week of class. And week 10 will be when we come back. Okay. So without further ado, let me go ahead and hand things over to our wonderful UIA.